distance between the jumper and the hill. Okay, so that's got to be the one. Okay, let's go take a look. So I'm gonna put the coordinate system. That's gonna be my x direction, and that's gonna be my y directions. Okay, so y is down. Remember, right? Now the motion in the x direction, the horizontal motion, we're going to be consider that as a constant velocity motion. Okay, motion of uniform speed. So the how much what is it? Yeah, the position of x is defined to be x naught plus. Let me just go ahead and say this: v naught xt plus 1/2 axt. But in this case, velocity in x direction is vox, which is 25, which is constant. So therefore, ax is equal to 0. So this doesn't come in. And I'm going to put the x naught over there so I don't have the initial x. So basically, x is determined to be 25t. Okay? Now, the y direction, the vertical, this is x directional. The vertical motion will be y, but this one is uniformly accelerated motion. So at any point, the jumper is going to feel the gravity, right? The acceleration in this case is g. So same thing. The vertical direction is going to be y naught plus vo y t plus 1/2 times a yt square. And the velocity y is equal to the initial velocity y plus ayt. And ay is g, in this case, 9.8 meter per second. Now I noticed that I didn't put the minus because I chose y in the direction of the gravity. So therefore, and this is gone, and the initial velocity in the vertical direction is not given, 0. So your y is equal to 1/2 times 9.8 t squared. The velocity along the in the y direction will be defined to be 9.8 t, and your acceleration is 9.8. So this is simple. Okay, when this guy land right here, he's traveled the x direction, how much? D times cosine, right? So this is going to be d times cosine 30 much. And the vertical position or travel that he did is d sine of theta. So this is y. This would be x coordinates. So x is what? When it land here, that's going to be d cosine of 30 is equal to 25t. So that's coming from this equation. Y, it traveled what? D sine of 30 is equal to 9.8 divided by 2t squared. So I have one equation and two equations. first and second equation. I don't know what the d is, and I don't know what the time is. So I have two equations and two unknowns. So I'm going to solve what the d is, which is going to be 25t divided by cosine of 30. And I'm going to substitute back in here. And that will give me 25t sine 30 cosine 30 equal to 9.8 divided by 2 t squared. So I have one equation and one unknown, but it looks like it's a quadratic. So let me check that. So 25 times sine is a cosine. Tangent. So that's going to give me 14.43 t. 9.8 divided 2 is 4.9 t squared. So I'm going to rewrite those. That's going to be 4.9 t squared minus 14.43 t equal to 0. Oh, okay. So that came out to be 4.9 t minus 14.43 equal to 0. So one of the t is 0, and the other one is 14.43 divided by 4.9. And you should have a 2.9448 seconds. Okay? And that's what it is. So it takes about 3 seconds for this person to land right here if the initial velocity is 25 meter per second in the horizontal. Okay, so when he jump, okay, that's what it is. Now the distance d that it wants, what we want to know is you can use either this or this. It doesn't really matter. So this looks very simple to me. So I'm going to substitute the t here. So my d would be 25, 2.9448 divided by cosine of 30. And let's see what the d is. About 85.00905. So 85. Okay. So so D is 85. But that guy is 85. Okay, so we check that. Okay. Okay, so what do we want? Oh, this height. Okay, so let's go ahead and study a little bit. That looks like a 45 to me. So this guy jump over. Okay. So we wanted to find this. Okay. Now we need to find the position. Okay. So this is the how much it traveled, x, and this is the how much it traveled, y. Okay. Now when you look at it here, if I drew the line, it looks like it has some symmetric nature. So if I can find the y, and I believe this distance would be equal to that y. Okay. So if it takes, what is it, 2.9448 seconds to get there, this looks like the time to get here is a 2.9448 divided by 2 seconds. Okay, so that's going to be looks like a 1.4724 seconds. Why? Because it looks very symmetric to me. Okay, so all I have to do is find the y when time is equal to 1.4724, and this case is 1/2 times 9.8 t squared. So t is right here. So if I were to compute, and I have about 10.623 meters. So this distance is 10.623 meters. And this is S, which is 10.623 meters. Okay, so that, I believe those are the answer, and this is how you wanted to do that. Okay, all right, okay, very good. Now again, you're gonna have to follow through, and if you hit the all 3 points, okay, you don't have a lot of things to do. You just have to continue on and cover more acreage. Okay, now if you are hitting some points but you cannot be able to match to my solution is, and you need to go back, and I gave you the step-by-step calculations, and you should know where you failed to make it. Okay. So let's say I don't know anything about this, and I just it's a blank basically. Then you need to start with the fundamentals and start working a little bit more harder in that cases. Okay, so I will be looking over your quiz tonight, and I'm gonna grade them. Okay, I want to know where you are at. Right. Okay, so that's it. Last time in chapter 12, we talked about the Newton's second law. Okay. When you say second law, that would be force is equal to MA. And it also goes for the same thing in the the force directions. I mean the vector directions. So what this means is force in the x direction is equal to m, the mass, times the acceleration in the x direction. And same thing in the y directions. And same thing for in the g directions. So I really don't like to read all this equation, and I'm just going to have to just use the vector format. This represents the fx, fy, fg. And the mass is the same. Acceleration is ax, ay, ag. Okay. Most of the time we'll be looking into a two-dimensional problems, but generally it works in that way. Okay. So this is what that meant. In one-dimensional case, just the F equal ma. Okay. Looking into the F equal ma, this is the force. The unit of the force is newtons. And then the English, the U.S. customary units, it's the pound. But
excuse me, Professor.
Yeah.
Can we record the lecture?
Oh, of course. Let me see this. Let me check the chat. Okay. Nope. Keep on doing it. Record. Okay. So this is a Newton, and this is pound force. Okay. Mass is the what? Kilograms. Okay. Generally, we use the kilograms. Grams or anything is okay. And U.S. customary, we called it a slug. Okay. And accelerations are given as a meter per second square. And this could be a foot per second square, sometimes inch per second square. And the 1 Newton is defined when we have 1 kilogram accelerating in the 1 meter per second square. So 1 is equal to 1 times 1 established. 1 pound force is when we have one slug and we accelerate that into a 1 foot per second square. So that's how the 1 pound is defined. And also the 1 pound of force is defined when we have 1 pound of mass, okay, designated as a LBM, and that guy to be accelerated as a 32.2 foot per second square. And here I can do something like this, right? So, so it's very difficult to conceptualize when you work with a pound mass. Okay, so you need to be a little bit careful. So the way how you want it to understand is, okay, if you have a something that you wanted to accelerate 1 foot per second square, and I want that to be 1 pound force, then if you get the one slug to accelerate this much, and then the 1 pound force is captured. But if it is pound mass, then you need to go ahead and, what is it, 32.2 pound mass. This much has to be smaller pound mass. 132.2 pound mass has to be accelerated in 1 foot second square. Then 1 pound of mass can be defined. So that's why the one slug is equal to 1 over 32.2 pound mass. Okay, so there is a conversion factor involved. But we are not going to use this concept. Okay, now the pound mass will show up if you are the aerospace engineer and use what is it? You're taking the propulsion classes. Okay, how much the force or the air, you know, uh, suck into it, right? And then pretty much everything is used in the pound mass. Okay, we need to convert that somehow. I don't know. At least I was taking the propulsion. Yeah, everything was in the pound mass, pound force. Okay. All right. So, and then the another concept was F equal to ma. Well, let's put it that way. And we know the acceleration is the v dt. The mass is always constant. We are not studying the special relativities where the mass might have been changing. But in in our classical mechanics, mass is not changing. So therefore, I can put this guy into a derivative inside, okay? And I'm gonna let this guy equal to symbol L. So dl dt, so that's gonna be L dot. So force is equal to L dot. Of course, this is also a vector format where L is mv. Okay, this is known as what? Linear momentum. Okay, momentum. Okay, so if there is a changes, time change, what is it? The changing in linear momentum with respect to time, that is a equivalent to the force. Okay, so how do we use this equation? Let me move that the heavy book away a little bit. So if I have a mass here, if I push with a some kind of a force, and this guy will move in the direction of the applied force with an acceleration of an a. So the mass here, if I were to push with the same force, and then this guy will move in that direction with a acceleration, same acceleration. If we're talking about the same mass and the same forces, only the direction is different. Okay, that's what it is. Now, you know, we love to, handle the weight dropping, right? Its weight is dropping. And we know the gravity pulls, right? I mean, that's the accelerations, right? And acceleration in this case is gravity. We know that that is given, okay? Or 32.2 foot per second square. You better know these figures, the numbers, okay? And so therefore, so in this case, the force that applied in here is equal to mg. Okay. Now this force is basically equivalent to your weight here. So you better know W is equal to mg. Okay. So W is equal to mg. This is the weight in pound or Newton, and this is the mass, slug, kilogram, and this is what, 32.2 or 9.8 meter per second square or foot per second square. So remember, so basically this is force is equal to ma, but this is a special case of this guy. Okay, so just remember those. Okay? So let's go ahead and do that. I have a about 200 pound. When I say pound, this is the force units. And sitting on the block. And it's a little bit rough. Okay. So, it's a little bit difficult to move this one when the surface is rough, or if surface is very, smooth, and if it's oiled, right, then it's a lot easier to slide, or if you push it slightly and this thing will move. Okay. So the problem here is, okay, you are going to apply some load at about 30 degrees, and the friction coefficient here is 0.25, okay, between these two surfaces. And I want this to be accelerated to the right about 10 foot per second square. And I wanted to find out how much force that I need to push this guy. Okay. Now I'm going to split the P into horizontal and vertical direction. So horizontal is P cosine of 30. Vertical is P sine of 30. Right? Now this guy is 200 pounds. So that's going to be representing as a weight is applied at the center, right? Okay, center of the geometric center, okay, because it looks like it's symmetric. Okay, and from the plate, and it's going to resist normally, and there is a force acting, from the plate to the block. And this guy were to move to the right, and because the surface is rough, so there is a friction force. Okay. Oops. So there is a friction force, which is opposite to the motion that I wanted to accelerate to the right, but you can't do that easily. You've got to overcome my friction. And this friction is defined to be friction coefficient times n. Remember, if the rougher the surfaces, and the coefficient will go up and friction will go up, and it's difficult to move. And if it is a smooth, then the coefficient of the friction will go down. Then the resistance force, the friction force, becomes reduced. Now, another thing is, boy, if things are very heavy, it doesn't matter what kind of surface that I have. It's gonna be difficult to push the heavier, uh, what is it, the mass. So heavier the mass will be more resistance to the motion than the lighter ones in this particular case. So now you know. So friction is defined. Okay. So hey, I'm gonna just go ahead and put hey, this is gonna be my x direction, and this is gonna be my y direction. Okay. Now I'm gonna take the summation over summation of the force in the y direction first is equal to 0. And this block, well, let me put it this way. Well, we say that the force is MA, right? So I'm gonna look at the y direction movements also. But however, this problem is designed the block to move in the x direction only, not the y direction. So there is no motion, up and down motion for the block. So therefore, this is 0. So this is a static problem. Okay. In the up and down motion is a static. It's not going to go anywhere. So summation of the force, I'm going to call that as a positive upward. So here they are, negative minus P sine of 30 and negative plus, not the plus, minus 200 pound. And the plus n is acting upward and has to be equal to 0. Okay. So n in this case is P sine of theta 30 plus 200 pounds. Okay, so first equation has been established. Now, oh my God. Okay. Now I'm going to take the F equal to MA in X directions. Right? Now the force is positive, to the right. So I'm going to go here. So here they are. P cosine 30. And then there is no other forces in here except minus mu times n, and no other horizontal forces are available. So all I have to do is mass times acceleration in the x direction. So I have second equations. Okay, I have n here, which I'm going to go ahead and punch that in here. So P cosine 30 minus mu is given, what is it, 0.25, I think. N is this guy, P sine of 30 plus 200. And the mass, remember, it's a W is equal to mg, right? The weight is equal to mass times the acceleration. In this case, it's a gravity. So there is a difference between a mass and the weight. Okay, weight is a force, mass is a mass unit. So mass times acceleration is the force. So weight is the force. So the m is basically W divided by g. The weight is 200 pounds divided by 9.8. So that's going to be 200 divided by 9.8. Now the acceleration is, we want to accelerate that. This is in pound, right? So sorry about that. So be careful. All right, don't mix that up. So then I need to use 32.2 instead of 9.8. So 32.2, and this would be 10 foot per second square. Okay, so watch out for that, the unit, okay? So now you have one equation and one, the unknown, which is a P, okay? So if you solve this guy, okay, I'm going to cheat a little bit. You see my notes? Yeah, the P is 151 pound force is required. So right here, it requires the load P is equal to 151 pound force is required, which is applied at the angle 30 in order for accelerate the 200 pound mass block to the right. We want to accelerate 10 foot per second square. Then we need a 151 pound of force at 30-degree incline. Okay. Now, if the data is 0, then this is just going to be force P is equal to mass, which is 200 divided by 32.2 times 10. So your P would be 62 pounds. Okay, so it's a lot easier to push this guy, accelerate the what is it? Maybe that's not right because of the friction. Well, let's go ahead and take a look at that. How about that? So here is the P here. The weight is 200 pounds. And this is going to be friction force. And I want to accelerate this guy to the right with about 10. So summation of the force in x direction equal to MAX. And the treading, the force to the right would be positive. P is positive. The friction force come in as mu n is equal to m times the acceleration 10. And the mass in this case is 200 divided by 32.2, 10 plus, this would be 0.25, the normal force. Normal force in this case is equal to weight. So that's going to be a 200 pounds. So let's see. So I need about 112, 11 pound needed to push that around. Okay. So, this guy is fairly responsible, for that. But anyway, so the 112. So if it is at the at 30-degree angle, then I need to push this guy 151 pound. But if the angle is 0, then 151 pound drops down to 112 pounds. Okay, so it's a little bit easier. Okay, so that's how we're gonna use uh, this type of equations, the F equal ma. All right. How about, okay, so here is a 100 kilogram block A, and it's on the roller. So which means that the friction is not considered. It's going to be at 0. And it is connected to a block B of a 300 kilogram. Okay. And this is probably held somewhere. Okay. So as soon as I let it go, this guy will drop down and this guy will move to the right. Okay. So we wanted to find acceleration of the block A and the acceleration of the block B. Okay. We know it's gonna move to the right and B will be moving downward. Okay. Now you're gonna have to establish what's called a free body diagram. This is for the block A. Okay. So there is the weight coming down, which is weight is equal to mg. So mass was given kilogram, and 9.8 meter per second square will be, what is it, 980 newtons, right? And still the normal force is acting upward, and also the tension in the cable pulls block A to the right. So this is the free body diagram. And block A is to move to the right. Okay. And for the block B, and this guy, the weight is equal to mg, which is 300 kilo, and the g is a 9.8 meter per second square. And this guy will be 3 times. That's going to be 29. 40 Newton is acting downward. Now you have, in this case, 2 cables of the, with the tension T. So you can replace this one with a 2T is acting in their case. But now the B is to move, with an acceleration downward. Okay. So going back up here, come on, and I wanted to find the equations. Okay. So the equation for, the summation of the forces in the y direction is virtually zero. Okay. Mass A will not go up and down. Okay. So in this case, your normal force is equal to weight, which is 980. Okay. Do we need that? I don't know. Okay. But but the A is going to be moving, okay, horizontally. So therefore, the forces in the x direction uh, is equal to that mass of A times the acceleration of A. Okay. So force in that direction, since it's moving to the right, and also acceleration is moving to the right, so it's in the collinear direction, and the only tension is pulling the mass of A to the right. Okay, so this is going to be 10 times acceleration of A. So this is your first equations. In here, now the block B, F equal to MA, block B in the horizontal directions, and there is nothing in it. Okay, so there is no force in the x directions, and therefore the B will not shake side to side. It will go up and down only. So this checked. The static equation checked. So in the vertical directions, okay, and the downward to be positive. So in this case, 2t is in the negative directions, plus weight is acting, and there is no other forces, and this mass of B will move downward, or in the same direction as the weight is applied. And that is going to be a second equation. So minus 2t plus weight in this case is 2940 right there. Mass is 300 kilo and AB. Now this is still the second one. So acceleration of the B is unknown. Tension in this case is unknown. And acceleration of the block A is unknown. And okay, so we have two equations. Unfortunately, we have three, what is it, unknowns. Okay, but look at over here. This A and the B is somewhat dependent each other. The position, velocity, acceleration is depend on this cable. Okay, so the length of the cable is not going to be changing. The length of A plus length of B, but in this case it's the two of them. So the acceleration of A, so I'm going to go ahead and do the double dot here. So this is going to be equal to 0, acceleration of A, not the double dot in this case. And the acceleration of B is kind of defined in that way. AA is equal to minus 2AB. But I'm going to go ahead and take the absolute value of it, because in this case, one is going down positive, one is going to the right positive. And if I were to reverse one of those, then, this plus minus makes sense. But using this relative equation to understand the motion of A depends on the motion of the B. The relationship is the acceleration A is going to be equal to 2 times of acceleration of the B. So that means the acceleration of B would be half of the acceleration of A because this double loop there. So this is the third equation that you need to know. So you have 3 equations and 3 unknowns now. Okay, so this is the first, this is the second, and this is going to be the third equations. Okay, so once you solve that, all 3, and then your solution is going to be coming out as A is going to be 8.4 meter per second square. A point B is going to be 4.2 meter per second square. And tension in this case came out to be 840 newtons. Okay, so you can go ahead and take a look at, or you can plug those values into, there, and you should be able to know this is the solutions. So this guy moves at 8.4 meter per second square. That guy will move 4.2 meter per second square. And pulling tension here is 840. And this guy is 2 times 840. Okay, so you are pulling it while this guy is moving, and because of 2, you see that force is equal to mass times accelerations. So you are actually pulling or resisting the motion of the P trying to going down, and that's why the acceleration is heft. And this guy is pulling to the right with a 840 with 100. So basically 840 is equal to mass is 100 times acceleration of 8. So F equal MA exists. Same thing in here. 2 times 840, and then the weight is equal to mass 300 times the 4.2 acceleration. So this is accelerate MA, and this is the summation of the force. Okay, so you can verify those. Okay, so I'm gonna continue on lecturing chapter 12 next week. Okay, and just like I did, just go ahead and take a look at the problem sets in the chapter 11 and 12, and there are solutions are given in the back of your textbook, and start solving it. Okay, and so that's
Professor, is there any specific problems that you want us to do, or do we just go and do anything? Any suggestions?
any problems are good enough for me, so I don't have any particular choice. There are so many different type of the motions, right? Some people what we worked on is somebody skiing off the hill, and another thing would be, hey, if I shoot the water in here, you know how far, how high, okay. uh some people you know shoot the rocket or whatever. Yeah, it's all same, but it come with a different color and shape and stories. To me, it doesn't really matter, right? So you should be able to select any one of those or two of those or many problems. If you can solve it, that'd be good. Okay, and if you hit the wall, just go ahead and email it to me. Hey, this is how much I did, and where do you think that I'm getting wrong? Then I can be able to help